Hi everyone, so I'm putting together a video series showing you how I'm building the Bluetooth communicators. I'm putting a new one together because there's some issues with the old one. But I wanted to run through first how I've built the old one and answer some of the questions that I've had. So a lot of people are asking me where I got it from. Well, the watch itself is actually from Starlight Studios. The circuitry inside is actually custom made, it's stuff that I've put together. And likewise the app that was on Android and still is on Android is actually a custom app that I built myself. So this series is going to be more about how I do it. It's not going to be a full tutorial on exactly how you can do it, but it's just going to give you a rundown, and if anyone wants to take inspiration from it and do one, please do, that'd be amazing. So what I'm going to do is I'm going to take the old one apart and I'm just going to show you exactly how this one was built, and I can talk through how I'm going to improve it with the new version. So I'll pop the lid off. So this is actually a custom mesh that I put in as well. It's much thinner than the one that comes with it, and it's got a bit of felt behind it. That actually leaves me some more room for the electronics. So inside, at the top here, we have this is a Pickaxe 14M2, and that's one that I put some custom programming on, and that's essentially the brains, I suppose, of the watch itself. And this here is a piezo transducer, and this is the bit that actually makes the beeping sound. Underneath that, we have this bit here, and this is the Bluetooth module. It's a serial-based module, so information is sent to this, that's then sent through to the Pickaxe, and the Pickaxe then decides what to do with that information, and that's what controls and makes the bleeps and such. On the sides here we have the two LEDs, and these then pop through the holes in the top here. Underneath we have a battery clip, and that's a CR2032, the same ones that are actually in the new legacy communicators. And finally on the side we have a switch here. So this is what controls the circuit, and that all again runs through the Pickaxe 14M2 here. Other components are just a few resistors placed throughout the circuit. The LEDs, for example, don't run at 3 volts, they're less than that, so that just keeps them safe. So that's actually pretty much it. That seems quite simple. There's quite a lot that goes into it because there's a lot of custom programming on this chip here on the Pickaxe, and I suppose the hardest bit actually was the Android software and making that work correctly. The issues that I've got with this are the battery does not last long at all. You're lucky to get a week out of it when it's not even being used. There's obviously an issue with the circuit somewhere. The other issue is that because the Bluetooth chip is on the bottom side, it doesn't get a lot of signal. So in the last video you'll see that the phone that I was using was actually next to the watch itself, and that's because it didn't work from much further away than that. So my plan is to replace the Bluetooth module and the Pickaxe with a single module that I've found, and then everything can go on top of the board here, and it's got a built-in antenna on the new module. So hopefully that will then allow more signal to come through. I mean, the issue is it's a metal watch and it's sort of surrounded by metal, so that does block a lot of the signal. So there's going to be a lot of trial and error in getting that to work. Yeah, so otherwise that's pretty much the old one. And in my next video I'll run through what I'm doing with the new one. I'm currently writing the firmware to go on the new chip, and I shall keep you posted. Thanks a lot.